All right, we're going to reverse a link, do another problem. An educative idiot keeps unemployment away. So we're reversing the linked list, and this time we are giving left and right positions that we want to reverse. So in this list, left is 1, and you're not counting from 0, so it starts from 1. And then right is 2, so you want to reverse the things between that window. So 6, 8, 7 becomes 8, 6, because these get flipped, 7. So that's the twist on the problem. So 2 and 4, this is number 2, this is number 4, so we're going to reverse just this part. As you see, 9 is the same, well, you get 280, right? And then, and so on. So from 1 to 5, 1, 2, 3, 4, 5, so the whole list gets reversed. From 2 to 5, so we have these blue, that's the window, that's what gets reversed. I think it should be understandable, just based off of that. And we can check our understanding. So from 1 to 5, 1, 2, 3, 4, 5. So start from 0 and then point to 1. So it should be this one. I can short circuit the evaluation. I don't have to step through every single one just to be sure, based on the options I have. And there's this figure it out, but I'm more interested in the diagrams, so I'm gonna skip that. Let's go to the diagrams. It's actually pretty neat. You just need a bunch of pointers, and the diagram makes why they're useful evident. So we have this list. We want to reverse from 2 to 4, so from 6 to 4 to node 4 here. That's what we want to reverse. We have a current pointer at the head. When we move to current, we see that we initialize this left pointer, and it is at the left of the beginning of the window. So and it stays there to start. Then we move to find the right pointer, iterate through to find the right pointer. So we have this current pointer that we can think of as the one that's going to point at the left position node, similar to that. What is the left position at the left position node? But we use it to find that, and we see that it's at 6. We iterate through this list and see that it's at 6. So we keep track of what was before it with this LPN node. So the previous node of the left position. Sorry, my words are weird right now, but we're almost there. So you now iterate forward to find if this right thing exists. If it exists, we point right node to it and point RPN to the next node after it. So 4 exists. Remember, we're going to flip this section. So our end points at the end. Then we keep track of what comes next, because we're going to flip this list and then reattach what LPN connects to the new head, and what the new tail will point to RPN. So now it's time to reverse this list. Fairly standard procedure. And then once you've done that, you just connect the next for LPN and connect the end of this reverse list to RPN, and you're done. And then what does that look like in code? So we have this modified reverse linked list function that takes in left and right. So this is what reverses the chunk that we end up getting when we find it. And it's fairly straightforward. The only difference is this left and right, that we're using to terminate our while loop instead of the usual current node. So if you've been following along, you're aware of like just how this way of reversing a linked list in place. Then this is the meat of our function, and it's well commented out. You can check it out. The same current from the diagram, LPN, that signals the start, right? The start of the window, like the entrance to the window, to the left node. The right node after the sublists, and the reverse head. So these are just some variables we're initializing. And then we use count to know whether we have gone through, like basically as a cursor to track the position we're at while we're looking through the list. So while it's less than left, we do the thing that helps us create this scenario here where current is pointing at what's at the left, and then this points at the entrance to it. That's what this does. And then if we find that if it's still active, if we're not at the end of the list, we're gonna find RPN next. So our count is less than right, whatever we specified as the right index that we want to check, we do something similar. This is how we find this position here, right here. So we loop setting right, RPN to right.next, increment the count so that RPN is going to be after the window, right after the window. LPN is right before the left index that we specified. RPN is right after the right index we specified. So that's what this does. Then if it exists, so if we don't fall off the edge of the cliff, or if the linked list goes on, we reverse that segment. The current is just like here, pointing at the head, as the head, and the left and the right. So we know when we're done. And that's what this function does for us real quick. While the right side and left, we decrement right until they match to mean that we are done looping through that list. And once that's done, we connect LPN to the reversed head, right? The new head of the linked list. So that's why we kept track. So we can connect this dot next to 4, which was going to be 4. And if RPN, if it exists, so basically, if there's a node here that should be connected to, let's say it's not null, it doesn't point to null, we loop through that list again because we have to find the tail of this list, this reversed list. And once we find the tail, we just connect the next to RPN. So what RPN is basically 2 in this case. So it's going to loop through 4, 7, 6, then connect 6 to 2. And if there's an LPN in the first place, return the original head if there are nodes before the sublist. So in this case, that's what we're going to do. The original head 3 is going to be returned. Otherwise, if the whole thing, if there are no nodes before the sublist, return the reverse head. So in that case, the window started from here. So the whole thing is reversed. So just return that head instead. And you're done. I think it's fairly straightforward. Thank you for watching. See you again shortly. An educative idea keeps unemployment away. Although you don't want to just aim for unemployment, you want to shoot for the moon. So an educative idea increases your career leverage, right? Especially when you share it on YouTube. So yeah, that's one reason I'm doing what I'm doing. And see you next time. Thank you. Oh, before I forget, my career leverage, I'm taking off one viral tweet that Naval Ravikant made a while ago about just boosting your leverage. Selling your sawdust. So learning is me sawing wood. This video would be the sawdust of my learning process. And selling it is very valuable. Again, an O of n algorithm and an O of 1 space algorithm, because the space you require doesn't grow with the size of the list, but the amount of computation you need does grow linearly with the number of nodes in your linked list. That's all. Thank you very much.